Yes, that's fine.
Thomas.
Good morning, everybody.
Good morning, sir.
I'm very late for the class. It was the first class. पहली class कौन सी थी?
So power system.
वो class engage होगी क्या?
जी sir.
Okay. As you know, we have been discussing this topic since yesterday. That's canonical state space realizations of transfer functions. And in this, we have already studied one canonical realization, that is first component form. Today we'll take up the second component form realization. I'm sure that the context of the lecture is clear to you. You are basically trying to realize transfer functions through state space models. And as you already know that you can have infinite state space models corresponding to a transfer function. So we are only discussing some canonical realizations. And in that, we have already discussed one canonical realization yesterday. We'll be taking up the second canonical form realization today. So I'll again start with the same transfer function, the general nth order transfer function. We'll consider the general nth order transfer function GS, which is actually equal to ys upon us, and which we have defined as beta naught s to the power n plus beta 1 s to the power n minus 1 plus beta 2 s to the power n minus 2 plus so on, beta n minus 1 s plus beta n upon s to the power n plus alpha 1 s to the power n minus 1 plus alpha 2 s to the power n minus 2 plus so on, alpha n minus 1 s plus alpha n. We have considered a strictly proper transfer function, wherein the degree of the denominator polynomial and the numerator polynomial is same. And furthermore, we have assumed the denominator polynomial to be a monic polynomial. What is a monic polynomial?
The coefficient of
Anybody?
Leading coefficient is 1, sir.
A polynomial for which the leading coefficient is unity. That means the highest degree term has got coefficient as unity. That is known as a monic polynomial. Now, like yesterday, I'll do some mathematical manipulations and try to get the state space realization in second component form for the given transfer function. So just follow the steps. So I'll cross multiply here. So I have got s to the power n plus alpha 1 s to the power n minus 1 plus alpha 2 s to the power n minus 2 plus so on, alpha n minus 1 s plus alpha n into ys is equal to beta naught s to the power n plus beta 1 s to the power n minus 1 plus beta 2 s to the power n minus 2 plus so on, beta n minus 1 s plus beta n into us. Is that clear? After that, what do? I combine the terms. Like s to the power n term is here as well as here. I'll combine these terms. So if I take s to the power n common, or I just combine the various terms involving s to the power n, what will I get? I'll get s to the power n ys minus beta naught s to the power n us. That's the first term I'll get. So I'll get s to the power n ys minus beta naught s to the power n us. This is the first term I'll get. Then s to the power n minus terms I will also combine, so I'll get s to the power n minus alpha 1 s to the power. I can even take this s to the power n common here. So if I take this s to the power n common here, like this. Okay. Then I'll take s to the power n minus 1. S to the power n minus 1, I will have alpha 1 ys minus beta 1 us. Alpha 1 ys minus beta 1 us, and then s to the power n minus 1. Isn't it? Plus I will have alpha 2 ys minus beta 2 us s to the power n minus 2 plus so on. And then I will have alpha n minus 1 ys minus beta n minus 1 us into s. Are you following me? Plus alpha n ys minus beta n us is equal to 0. Is that clear?
Yes, sir.
Okay. Now what I'll do is I will evaluate this equation for ys. For this ys, so ys is equal to, if I take this term on that side, what do I get? I get beta naught us into s to the power n. So here, or this will be s to the power n ys actually, plus beta 1 us minus alpha 1 ys s to the power n minus 1 plus beta 2 us minus alpha 2 ys s to the power n minus 2 plus so on, beta n minus 1 us minus alpha n minus 1 ys into s plus beta n us minus alpha n ys. Is that clear? Yes. Is that okay?
Yes, sir.
Yes, sir.
Now what do? I divide throughout by this s to the power n. What do I get? Ys equal to beta naught us plus 1 upon s beta 1 us minus alpha 1 ys plus 1 upon s square beta 2 us minus alpha 2 ys. Is that okay? Plus so on, plus this term will become 1 upon s to the power n minus 1, 1 upon s to the power n minus 1. Then I have beta n minus 1 us minus alpha n minus 1 ys. Okay. And then plus last term is plus plus 1 upon s to the power n beta n us minus alpha n ys. Is that clear?
Yes, sir.
So this is your ys, isn't it? Now what I do is, corresponding to this equation, I draw a state diagram. Now what is ys equal to? It is the sum of all these terms. As you can see here, these are integrated terms. 1 upon s, 1 upon s square, इसमें अगर आप देखोगे 1/s⁴n जो है मैक्सिमम ये पावर वाली टर्म है इसमें. So this actually corresponds to n integrators, isn't it? This corresponds to n minus 1 integrators. This corresponds to 2 integrators. This corresponds to 1 integrator, and so on. So I'll just make the simulation diagram corresponding to this, just like I showed you yesterday how to make the simulation diagram. So what is ys equal to? Sorry. Ys is equal to beta naught us. So if I make it in time domain, I will have yt equal to beta naught ut. So let me make a simulation diagram corresponding to this. So this is, let's say, ut. It's like this. This is beta naught. This is a summing block here. This is plus, and this is yt. Yt has many terms. One of the terms in yt is beta naught ut. Is that clear?
Yes, sir.
है ना पहली वाली टर्म yt is equal to beta naught ut. सेकेंड वाली टर्म क्या है? इंटीग्रल ऑफ, दिस इज प्रोडक्ट, ये इंटीग्रल प्रोडक्ट में आ रहा है, बीटा 1 ut माइनस अल्फा 1 yt, जब टाइम डोमेन में लेंगे हम, isn't it? So this is beta 1 ut minus alpha 1 yt. Let's draw it. Beta 1 ut minus alpha 1 yt. Beta 1 ut. This is beta 1. This is your ut here, isn't it? This is beta 1 ut. Yt is here minus alpha 1 yt. So I have a summing block here. Like this. This is plus. So this becomes beta 1 ut. Then I have alpha 1 yt. So it's like this. It's like this. And like this. This is alpha 1. And this is minus. So this output here is beta 1 ut minus alpha 1 yt. And it's to be multiplied by 1/s. That means the integrator. It's integrator will show like this. Integrator हम ऐसे दिखाते हैं. So it's like this. So this is plus here. ये वाली टर्म 1/s वाली टर्म है लाप्लास डोमेन में. ये आपका बीटा 1 ut हो गया टाइम डोमेन वाला. ये आपका अल्फा 1 yt हो गया और 1/s को मैंने रिप्लेस कर लिया इंटीग्रेटर से. तो ये वाली टर्म मैंने सिमुलेशन डायग्राम में रिप्रेजेंट कर ली. ये जो सेकंड वाली टर्म थी यहाँ पे, this one. Could you understand this? Because my
Yes, sir.
yt is not ut, then this term added to it. So I have just made this term on the simulation diagram and added it to this term. Similarly, I have so many terms, like n terms like this. Second वाली term भी हम लिख लेते हैं. This is beta 2 ut minus alpha 2 yt multiplied by 1/s square, isn't it? So you have got beta 2 here. It's to be added to this is alpha 2. So this is minus alpha 2 yt, beta 2 ut minus alpha 2 yt, then 2 integrators. एक तो आ गया ऑलरेडी. अगर मैं एक और इंटीग्रेटर यहाँ पे दिखा दूं, it's like this. So multiplied by 1/s, then there is again 1/s. So that makes it 1/s square. Do you get me? Yes. ये वाली टर्म जो मेरी है, ये वाली टर्म जो मुझे ऐड करनी है, व्हाट्स दिस टर्म एक्चुअली? दिस टर्म इज बीटा 2 ut minus alpha 2 yt multiplied by 1/s square. So this is 1/s, 1/s added to. So that gives me the second term. So similarly, I move on. So I show a dotted line here like this because I have so many integrators. I cannot show all of them. So it will again move like this. तो यहाँ से ये आगे जाएगा. यहाँ से ऐसे ही बहुत सारी ब्रांच होंगी इसकी. तो मैं आप लास्ट की 2 ब्रांच दिखाऊंगा. लास्ट की दो ब्रांच मेरी ये हैं, दैट इज बीटा n माइनस 1 ut माइनस अल्फा n माइनस 1 yt. बीटा n minus 1 ut. So this is, let's say, beta n minus 1. So it's like this. Minus alpha n minus 1. Alpha n minus 1. So it's like this. This is plus and this is minus. और इसमें कितने इंटीग्रेटर्स आगे होने चाहिए? S to the power n minus 1. So it will be like this, one more integrator, and then there will be dots like this, like this. There will be so many integrators. अभी तक n minus 1 integrators आ गए हैं. Is that clear? Then this last term. So last term is beta n ut. It's like this. ये beta n हो गया. थोड़ा सा इधर क्यूब बनाते हैं so that I get a space for drawing the integrator also. So this is your beta n. Then this is the summing block here. This is plus. ये आपका alpha n हो गया. This is plus and minus. Then this is an integrator, nth integrator. ये आपका nth integrator आ गया. तो इस चेन में जैसे प्रीवियस केस में टोटल n इंटीग्रेटर्स थे, इसमें भी n इंटीग्रेटर्स हैं, लेकिन कॉन्फ़िगरेशन डिफरेंट है. Is that clear? So you add all these terms. So basically your yt, अगर हम टाइम डोमेन में देखेंगे इसको, क्योंकि सिमुलेशन डायग्राम टाइम डोमेन में ही बनाई जाती है, तो अगर आप इसको टाइम डोमेन में देखोगे, दिस विल बी yt इक्वल टू बीटा नॉट ut, जो कि पहली वाली टर्म मैंने बनाई. देन बीटा 1 ut माइनस अल्फा 1 yt इनटू 1 अपॉन s, मींस इसके साथ एक टर्म आनी चाहिए इंटीग्रेटर की. बीटा 2 ut माइनस अल्फा 2 yt के साथ दो टर्म्स आनी चाहिए, जैसा कि हमने देखा आ रही है यहाँ पे. इसके साथ दो इंटीग्रेटर्स आ रहे हैं. और ऐसे ही जब आप जाओगे बीटा 3 वाले के साथ तीन इंटीग्रेटर्स आएंगे. एंड वंस यू रीच n minus 1, उसके साथ चेन में n minus 1 इंटीग्रेटर्स आ जाने चाहिए. और लास्ट वाली टर्म के साथ you'll have n इंटीग्रेटर्स. Is that clear? Is that okay?
Yes, sir.
Yes, sir.
So this is the state diagram as we have called it, or analog computer simulation diagram. इसमें भी देखो आप जो सारी टर्म्स हैं उनको आप फिजिकली रियलाइज कर सकते हो यूजिंग सिंपल ऑप-एम्प सर्किट्स. Just have integrators, summing blocks, and the comparator blocks or addition blocks. So gain blocks. So that's all what we have got here. So this is a complete state diagram. ये last वाले केस में हमने state diagram दो steps में बनाई थी, लेकिन इसमें जो procedure है वो थोड़ा different हम follow कर रहे हैं. So now this ut I will draw here so that you don't have any confusion. This is ut here, and like this. Now I have to obtain the state space. I have to define the state variables. So what is the rule I have told you for defining the state variables?
Right to left, sir.
No, that's not the rule. The rule is that the output of integrators are to be taken as state variables. Isn't it? Outputs of the integrators are to be taken as state variables. और जो मैंने लास्ट टाइम राइट टू लेफ्ट कहा था वो मैंने कहा था अगर आपको फर्स्ट कंपेनियन फॉर्म में, फर्स्ट कंपेनियन स्टैंडर्ड फॉर्म में अगर आपको चाहिए canonical realization system की, तो उस केस में you have to name the state variables from right to left. That's what I told you, isn't it? So basic rule
Yes,
is
sir.
that the basic rule is that the outputs of the integrators are to be taken as state variables. तो इसमें कितने integrators हैं total?
N, sir.
N integrators. How many state variables will be there? How many state variables will be there?
N, sir.
N state variables. So the same rule will remain same. The outputs of the integrators will be chosen as state variables. Outputs of integrators to be chosen as state variables. And in order to get the realization in standard second companion form, we name the state variables from left to right. स्टैंडर्ड सेकंड कंपेनियन फॉर्म में रियलाइजेशन के लिए ये जो मैंने स्टेट डायग्राम बनाई, n इंटीग्रेटर्स हैं तो n स्टेट वेरिएबल्स होंगे और इन n स्टेट वेरिएबल्स में से जो इंटीग्रेटर पहले आएगा उसके आउटपुट को हम पहला स्टेट वेरिएबल मानेंगे. So this output will be x1. Is that clear? These are the states I am defining. The output of this integrator, I will call this as x2. This is the output of last integrator. What will be this? This will be xn. और इससे पहले वाले इंटीग्रेटर का आउटपुट क्या होगा? That will be xn minus 1. Is that okay? So as a general rule, the outputs of the integrators are chosen as state variables. And in order to get the realization in standard second companion form, I am naming the state variables from left to right. Is that clear? Clear to all?
Yes, sir.
Now I am going to write down the state equations. So for writing the state equations, if this is x1, what will be this in this variable? This one?
X1 dot, sir.
X1 dot. Very good. This will be x1 dot. And this one will be what? x2 dot. सही है ना? ये वाला वेरिएबल जो होगा, this will be xn dot. और ये वाला वेरिएबल जो होगा, this will be xn minus 1 dot. सही है?
Yes, sir.
मैं स्टार्ट करूंगा. Equation लिखना स्टार्ट करने के लिए, just to keep the thing simple, I'll first of all write down the equation for xn dot. आप देखो ये xn dot इस summing block का आउटपुट है. What is xn dot equal to? इस पे कितनी सिग्नल्स ऐड हो रही हैं? एक तो ये वाली सिग्नल, ये वाली सिग्नल, ये वाली सिग्नल. Because you must have already read in block diagram algebra, the signal at the output of a summing block is the sum of all the signals that enter the summing block. Now see here, this xn dot, it will be equal to what? Just see. Help me. What will be xn dot equal to? I am writing down the state equations now. So xn dot will be
ut beta 1 plus xn minus 1.
xn minus 1. xn dot equal to ये वाला जो सिग्नल है, it will be xn, ये वाला सिग्नल xn minus 1 है ना? तो xn minus 1 plus beta 1 u, सही है? Minus alpha 1 y. Is that okay?
Yes, sir.
Or I can write xn dot equal to, क्योंकि आपको पता है कि स्टेट की इक्वेशन में y नहीं आता, so xn dot equal to xn minus 1 plus beta 1 u minus alpha 1 into, what is y equal to? Y is equal to beta naught u plus xn. Isn't it?
Yes, sir.
Yes, sir.
Instead of y, I can write down xn plus beta naught u. Is that okay? Or I can write xn dot equal to xn minus 1. u वाली terms में combine कर लूंगा. तो plus beta 1, या पहले xn वाली term लिखेंगे. xn minus 1. Then we have got minus alpha 1 xn. सही है? Minus alpha 1 xn plus beta 1 minus alpha 1 beta naught into u. Is that okay?
Yes, sir.
कहीं पे मैथमेटिक्स में गलती हो जाए, please interrupt me. So this is your equation for xn dot. Similarly, I write down the equation for xn minus 1 dot.
Sir, please repeat the equation for xn dot.
Okay, I'll repeat. So your xn dot is this variable, isn't it? Just look at the simulation diagram.
Yes, sir.
This is your xn dot. This is the output of this summing block. So this xn dot will be this signal plus this signal plus this signal. This one is xn minus 1. So that's it here. Plus beta 1, and this one is u. So beta 1 u. minus alpha 1 y. Is this first equation clear?
Yes, sir.
Okay. Then xn dot equal to xn minus 1. I have written it as it is, plus beta 1 u minus alpha 1. Then instead of y, you can see this y is equal to what? Y is equal to xn plus beta naught u, because this signal is u actually. Isn't it?
Yes, sir.
So instead of y, I am writing xn plus beta naught u. Then xn dot equal to xn minus 1 as it is, minus alpha 1 xn from this. Then plus, I am combining the u terms. So beta 1 minus alpha 1 beta naught into u. Is that clear?
Yes, sir. Got it.
Okay. Now this is the equation for xn. Similarly, I will write xn dot. Similarly, I will write down the equation for xn minus 1 dot. ये देखो, ये xn minus 1 dot है. By the same analogy, as you can see here, xn dot में यहाँ पे xn minus 1 था. xn minus 1 dot में ये वाली सिग्नल जो होगी, this will be xn minus 2. Isn't it? Are you following me?
Yes, sir.
This will be xn minus 2. So xn minus 1 dot will be equal to xn minus 2 plus beta 2 u minus alpha 2 y. Is that okay?
Yes, sir.
So
Yes,
I will
sir.
have xn minus 1 dot equal to xn minus 2 minus alpha
Plus.
2 xn और पहले लिखते हैं, no, not minus alpha 2 xn. I'll write down the complete equation, plus beta 2 u minus alpha 2 y. Is that okay? So I will have xn minus 1 dot equal to, so this is xn minus 2 plus beta 2 u minus alpha 2. Instead of y, as I wrote here, y is equal to xn plus beta naught y, or beta naught u. Is that okay?
Yes, sir.
Or I can write xn minus 1 dot equal to xn minus 2 minus alpha 2 xn, u वाले टर्म्स को कंबाइन करेंगे, प्लस बीटा 2 माइनस अल्फा 2 बीटा नॉट u. Is that clear? तो ये आपकी फर्स्ट इक्वेशन है, ये आपकी सेकंड इक्वेशन. सही है? By the same analogy, can you tell me what will be xn minus 2 dot equal to? Similarly, xn minus 2 dot will be equal to what? Yes, just help me.
N minus 3.
Last वाली equation आप मुझे बताओगे. xn minus 3, then minus alpha 3 xn
Alpha 3xn
plus
beta 3
Beta 3.
beta 3 minus alpha 3 beta naught into u.
beta naught.
Is that clear?
Yes, sir.
This
Yes.
will be your equation number 3. Okay. So you go on writing the equations like that, and finally you reach here. ये वाली equation जो है x2 dot की. x2 dot will be equal to what? x2 dot will be equal to x1 plus beta n minus 1 u minus alpha n minus 1 y. Isn't it? So your x2 dot will be equal to what? x2 dot will be equal to x1, okay, minus alpha n minus 1 xn. So here plus, या पूरी इक्वेशन लिखूं मैं, just to make the things clear to you. Let me write down the steps for this. Are you just looking at the board, or are you writing also something?
So writing.
हाँ, लिखने से easy हो जाएगा. So you'll have x2 dot equal to x1 plus beta n minus 1 u minus alpha n minus 1 y. Just look at the simulation diagram. So you have got beta, this x2 dot equal to x1 plus beta n minus 1 u minus alpha n minus 1 y. Is that okay? Yes.
Yes, sir.
So this is your extent. It's like this. Now, by the same substitution, so instead of this y and what will I write? So it will be actually x2 dot equal to x1 plus beta n minus 1 u minus alpha n minus 1. Y की जगह क्या लिखेंगे हम? Y is equal to xn plus beta naught u. Is that clear? So now my x2 dot will be equal to x2 dot is equal to x1 minus alpha n minus 1 xn. Then u terms I will combine, so that is plus beta n minus 1 minus alpha n minus 1 beta naught into u. Is that clear? ये बन गई x2 डॉट की इक्वेशन. अब मेरी लास्ट इक्वेशन मैंने लिखनी है x1 डॉट की. So x1 dot की equation similarly. So equation for x1 dot, what will be that equal to? x1 dot. देखो अब x1 dot की equation. Just look at the x1 dot equation. What is x1 dot equal to? See here, x1 dot is this. ये वाली equation बाकी equation से different है क्योंकि इसमें ये वाला input नहीं है. x1 dot is beta n u minus alpha n y. Is that clear? Yes.
Yes, sir.
x1 dot is equal to beta n u minus alpha n y. Beta n u minus alpha n y. So x1 dot is beta n u minus alpha n y. So that means x1 dot is equal to beta n u minus alpha n. What do we write instead of y? Y is equal to xn plus beta naught u. So x1 dot is equal to minus alpha n xn. Then we will combine these two plus beta n minus alpha n beta naught into u. Is that okay? तो बन गई आपकी सारी इक्वेशंस. ये वाली इक्वेशन आपकी फर्स्ट इक्वेशन है, ये सेकंड है, ये थर्ड है. ये वाली इक्वेशन का नंबर क्या होगा? दिस विल बी n minus 1th इक्वेशन एंड दिस विल बी द लास्ट इक्वेशन. टोटल इक्वेशंस आपके पास n है, isn't it? Is that clear?
Yes, sir.
Now we write down all these equations in matrix form. This one will be equation number. This is equation number n minus 1 and this is equation number n, isn't it? So we write down all these equations in matrix form. So how do I write down these equations? Let me write down. Writing these n equations in matrix format. What do I get? I like this. So this is x1 dot, x2 dot, so on. Then you have got xn minus 2 dot, xn minus 1 dot, and xn dot. That's equal to, so I have a matrix here. Then what do I have here? I have x1, x2, so on, xn minus 2, xn minus 1 and xn. और प्लस मेरे पास दूसरा मैट्रिक्स होगा u वाला, है ना? Now what is x1 equal to? It is equal to minus alpha n xn. तो बताओ मुझे पहले वाला रो क्या होगा इसका मैट्रिक्स का? Yes. x1 डॉट की इक्वेशन बताओ मैं कैसे लिखूं मैट्रिक्स फॉर्म में?
सर एंड वाला एलिमेंट 1 होगा,
0
बाकी सारे
1 सर.
बाकी zeros होंगे. So this will be 0, 0,
Zero.
सारे zeros except the last one, which will be 1. Isn't it? x2 dot. x2 dot ये है. बताओ x2 dot में क्या होगा? So this is not 1. Who told me it's 1? It's not 1, it's minus
Minus
alpha.
alpha n.
है ना? This is minus alpha n. Now tell me about the second equation. x2 dot is equal to x1. That means first term is going to be 1. ये वाली equation, this equation. Then minus alpha n minus 1 xn. That means all zeros except the last one, it is going to be minus alpha n minus 1. Is that clear? So this is going to be minus alpha n minus 1. Okay? So and so on. जैसे मान लो x3 डॉट की जो इक्वेशन होगी, आप मुझे बोल सकते हो कि x3 डॉट की इक्वेशन क्या होगी? x3 डॉट की इक्वेशन में x2 होगा और यहाँ पे माइनस अल्फा n माइनस 2 xn होगा. Can you write down the equation for x3 dot? What will be like?
Sir 0 0 0 1 0 0 0 और लास्ट पे फिर minus alpha n minus 2.
It will be 0 1 x3 dot वाली equation. It will be like this. 0 0 and then last term minus alpha n minus 2. है ना? Similarly, you move on like this. That is, then you have got xn minus 2 dot equation. वो मेरे पास है वो वाली equation. xn minus 2 is equal to xn minus 2 dot is equal to xn minus 3. xn minus 3 कहाँ पे होगा? This is xn minus 1, xn minus 2. xn minus 3 will be the fourth term here. So this will be actually be 0. All zeros here. Fourth term जो यहाँ से होगी, that means this will be 1 here. And then there will be 0, 0 and minus alpha 3. Minus alpha 3 है. xn minus 2 डॉट की इक्वेशन में xn minus 3 है. अभी मैं वो वाला u वाला टर्म नहीं लिख रहा हूं. Then I have got minus alpha 3 into xn. Minus alpha 3 into xn. Is that okay? Then I have xn minus 1 dot. This one, this equation. What is xn minus 1 dot equal to? It's equal to xn minus 2. Means xn minus 2 वाली टर्म पे 1 है. वो तीसरी टर्म है पीछे से. So it's like this 0, 0, 0, like this. This is 0, then this is 1. 0, and this term is minus alpha 2. Are you getting me?
Yes, sir.
And then the last equation, that is xn dot. xn dot कहाँ पे लिखा था मैंने? xn dot यहाँ पे लिखा था हमने. xn dot की equation में xn minus 1 है. That's equal to 1. And then there is minus alpha 1 with xn. xn minus 1 dot की equation में you have got, sorry, xn dot की equation में you have got 0, 0, 0, 0, 0, then this is 1 here, and this is minus alpha 1. Is that okay? अभी u वाली टर्म्स मैंने लिखी नहीं. आप देखो x1 डॉट की इक्वेशन में u का कोफिशिएंट क्या है? बीटा n माइनस अल्फा n बीटा नॉट. So this is beta n minus alpha n beta naught, isn't it? Then x2 dot की equation में you have got beta n minus 1 minus alpha n minus 1 beta naught. तीसरी इक्वेशन में by the same analogy you will have beta n minus 2 minus alpha n minus 2 beta naught. So on. अच्छा, इसमें xn वाली इक्वेशन में लास्ट वाली इक्वेशन में क्या है? या xn minus 2 डॉट वाली इक्वेशन में क्या है? बीटा 3 minus alpha 3 beta naught. तो बीटा 3 minus alpha 3 beta naught. इस वाली इक्वेशन में बीटा 2 minus alpha 2 beta naught. और इस वाली इक्वेशन में बीटा 1 minus alpha 1 beta. Is that clear? Yes.
Yes, sir.
There's no rocket science involved. You just have to write down the equations in matrix format properly. And if you do it methodically, you will be able to write it. In case anybody has any confusion or any doubt, you can ask me. Yes. ये बन गया आपका स्टेट मॉडल, स्टेट इक्वेशन बन गई आपकी ये। और इसका ये वाला स्ट्रक्चर जो है मैट्रिक्स ए का, this is a special structure. What is so special in this? The speciality in this is that the first n minus 1 columns have got all entries 0 except the entries in the subdiagonal. What's the subdiagonal? Subdiagonal is the diagonal below the main diagonal. ये वाला जो ये subdiagonal है, इसमें सारी एंट्रीज 1 है। जैसे मान लो अगर आपके पास एक मैट्रिक्स है, जैसे 1 2 3 4 4 1 6 2 2 4 1 3 1 5 1 1, इसमें डायगोनल तो ये है, this is the super diagonal and this is the sub diagonal. Do you get me?
Yes, sir.
This is the main diagonal, this is the super diagonal, and this one is the sub diagonal. तो ये वाला जो मैट्रिक्स है, इसमें स्पेशलिटी क्या है? इसमें स्पेशलिटी ये है कि पहले वाले n-1 कॉलम्स जो हैं इसके, उनमें सभी एंट्रीज 0 हैं एक्सेप्ट द एंट्रीज इन द सब डायगोनल व्हिच आर ऑल वंस, एंड द लास्ट कॉलम हैज गॉट नॉन जीरो एंट्रीज. इज दैट क्लियर?
Yes.
और लास्ट वाले कॉलम में जो एंट्रीज हैं वो एंट्रीज सारी हैं वही एंट्रीज हैं जो कि आपकी डिनोमिनेटर पॉलिनोमियल में होती हैं, अल्फा n minus 1 with the negative sign and written in reverse order, right, starting from alpha n to alpha 1. Is that clear? This structure, this matrix structure, wherein the first n columns have all entries 0 except the entries in the subdiagonal which are all ones, and the last column has got all non-zero entries. This is known as the matrix in second companion form. ये वाले matrix को matrix literature में second companion form matrix कहते हैं. And that's why this realization is known as second companion form realization. I'm sorry for the interruption. So this type of matrix structure in matrix theory is known as second companion form structure. So what are the characteristics of the second companion form matrix? Anybody?
So subdiagonal elements are 1.
The first n columns have all entries 0 except the entries in the subdiagonal which are all ones, and the last column has got non-zero entries. Is that clear? And could you identify the relation between the first companion form and second companion form? Can you see some sort of relation between the two?
So
So the A
transpose.
matrix is transpose.
They are transposes of each other, isn't it? They are transposes of each other. और इसमें जो B मैट्रिक्स है, B मैट्रिक्स का ये स्ट्रक्चर, अगर आप इसको कंपेयर करो कल के फर्स्ट कंपेनियन फॉर्म के साथ, दिस इज एक्चुअली द ट्रांसपोज ऑफ योर C मैट्रिक्स. जो हमने फर्स्ट कंपेनियन फॉर्म में जो C मैट्रिक्स बना था हमारा, सो उसका ये ट्रांसपोज है, isn't it? Is that okay?
Yes, sir.
So this is the second companion form realization of a transfer function. Now one more thing you will notice here, as I told you yesterday also, ये जो बीटा नॉट वाली टर्म है, क्योंकि इसमें d बीटा नॉट के बराबर है, फीड फॉरवर्ड वाली टर्म बीटा नॉट है. So just in case of yesterday's state diagram, you can see here that beta naught is the direct link from ut to yt, isn't it? बाकी जो सभी टर्म्स हैं जैसे बीटा 1, बीटा 2, बीटा n, वो इंटीग्रेटर्स के थ्रू जाती हैं. ये वाली टर्म डायरेक्टली जाती है फ्रॉम ut to yt. That's why this is known as the feed forward term. Is that clear? और feed forward term तभी आएगी because it's equal to beta naught, And beta naught, as you can see in the transfer function, what is beta naught? Beta naught is basically the coefficient of s to the power n in the numerator. So if the transfer function is a strictly proper transfer function, then only this beta naught is going to be non-zero. And you will be having a feed-forward term in the state space realization. In case the transfer function is proper, that means the degree of numerator is less than the degree of denominator. Beta naught will be equal to 0. So you will not have any d term in the transfer function. Is that clear? सही है कि नहीं?
Yes, sir.
Yes,
Okay.
sir.
अभी हमने स्टेट इक्वेशन तो लिखी है, अब आगे हमने कौन सी इक्वेशन लिखनी है? We have to write one more equation. That's the output equation, isn't it? Now I write down the output equation. So what is the output equation? Yes, tell me. Output equation is y is equal to, just look at the simulation, look at the diagram, look at the simulation diagram. What is yt equal to? What is y equal to?
Xn plus beta naught u, sir.
Xn plus beta, no, xn plus beta naught u, yes. It's equal to xn plus beta naught u. So I have got y equal to xn plus beta naught u. So let me write down this equation in state form, in the matrix form. So I'll have 0, 0, 0, so on up to 1. Then I've got x1, x2, so on. This is xn minus 1 and then xn, isn't it? Plus beta naught into u. सही है? ये आपका C मैट्रिक्स है. Y is equal to xn plus beta naught u. अगर आप देखो फर्स्ट कंपेनियन फॉर्म के साथ इसको कंपेयर करो, it is basically the transpose of your B matrix that you got yesterday. फर्स्ट कंपेनियन फॉर्म में जो B मैट्रिक्स मिलता है ये उसका ट्रांसपोज है, और D वाली टर्म सेम है, दैट इज बीटा नॉट. तो अगर आपका ट्रांसफर फंक्शन प्रॉपर है तो उस केस में ये बीटा नॉट 0 होगा, तो ये वाली टर्म एग्जिस्ट नहीं करेगी, और ये वाली टर्म भी, ये वाला मैट्रिक्स भी सिंपलीफाई हो जाएगा इन केस योर ट्रांसफर फंक्शन इज प्रॉपर. In that case, beta naught will be 0. So this matrix will be simply beta n minus 1, beta n minus 2, so on up to beta 1. Is that clear? So this is the second companion form realization of a transfer function. And why is it called second companion form? Because this matrix structure is known as second companion form. और अगर हम इन दो फॉर्म्स को आपस में कंपेयर करें, जो हमें फर्स्ट कंपेनियन फॉर्म और सेकंड कंपेनियन फॉर्म मिला था, फर्स्ट कंपेनियन फॉर्म and second companion form, तो इसमें हम देख रहे हैं अगर ये मैट्रिक्स, अगर इसमें जो मैट्रिसेस चार हम मैट्रिसेस हमें मिले, इफ वी कॉल देम एज A C B C C C and D C, where this subscript C refers to, let's say, first companion form. Okay. And if we have the second companion form matrices represented like this, A naught, B naught, C naught and D naught, चार मैट्रिसेस जो स्टेट स्पेस मॉडल की हैं, तो इसमें रिलेशन क्या है आपस में? A naught जो है that's equal to AC transpose, isn't it? सही है ना? And what is B naught equal to second companion form वाला जो B है वो इसके C का ट्रांसपोज है, और इसका जो C है वो इसके B का ट्रांसपोज है, तो D आपस में बराबर है. D naught is equal to DC. And since you know, because they are single entries, so D naught equal to DC can even be written as D naught equal to DC transpose. That becomes one and the same thing. Is that okay? जैसे मान लीजिए अगर आप किसी स्केलर का ट्रांसपोज देते हो बीटा नॉट का, that still remains बीटा नॉट, isn't it? Are you following me?
Yes, sir.
तो ये वाली रिलेशन अगर दो स्टेट स्पेस मॉडल्स में हो, we call them duals of each other. What do we call them?
Duals of each other.
Duals. So the first component form and second component form matrices are duals of each other. So this principle of duality is actually exploited in control theory. We'll see later on that we exploit it in designing controllers for the state space model. So this is the second component form realization, and this is the relationship between the first component form and the second component form. अब मान लो आपको एक ट्रांसफर फंक्शन दिया गया है, जैसे you have been given a transfer function like gs equal to s cube plus 3s square plus 2s plus 1 upon s4 plus 5s square plus 6s or 5s cube 6s square plus 3s plus 5. And I tell you, write down its by inspection only. You write down its realization in second component form. Can you write it? How many state space model state variables will it have?
4.
4 degree of the denominator polynomial. So you'll have x1 dot, x2 dot, x3 dot, and x4 dot. Isn't it? All that be equal to? So this is here x1, x2, x3, and x4. So you have got first n minus 1, that means first 3 columns, all entries 0 except the subdiagonal. So this is first 3 columns. So this will be what? 0? Yes, tell me. Except the subdiagonal, all entries are 0. So kahan pe 1 aana hai? Yes. What will be x1 dot equal to?
Sir, 0, 0, 0 और last में -5.
0, 0, 0 और last में -5. Then?
So 1, 0, 0, -3.
1, 0, 0, -3. Then 0, 1,
0, 1, 0,
-6.
and 0,
0, 0, 1,
1
-5.
minus
सही है? Plus, since you see that it is a proper transfer function, degree of numerator polynomial is less than the degree of denominator polynomial. So in this case, the B matrix you can write simply as, what will be the entries of B matrix? There will be 1 written in reverse order. That's 1, 2, 3, and 1, and U. क्योंकि इसमें बीटा नॉट है ही नहीं, isn't it? So you'll have simply beta n minus 1. That means beta 4 beta. इसमें क्या कितने टोटल ये हैं? 1, 2, 3, and 4. So you'll have these written in the reverse order. That is 1, 2, 3, and 1. Is that clear? Yes. Is that okay?
Yes, sir.
Yes, sir.
Okay. ये हो गया आपका. This is your state equation. What will be the output equation? Y is equal to 0, 0, 0, 1, x1, x2, x3, and x4. Is that clear? So just by inspection, you can write down the, because this is the C का, C is basically B transpose. जो B आपको मिला था फर्स्ट कंपेनियन फॉर्म में. फर्स्ट कंपेनियन फॉर्म में B का स्ट्रक्चर कुछ ऐसा होता था, 0, 0, 0, लास्ट एंट्री 1. तो इसमें वो C का स्ट्रक्चर है, because it's the dual of first companion form. Is that clear? So this is how you can, just by inspection, you can write down the state space model in second companion form, just as you could write down the state space model in first companion form. Is that okay? And as I told you yesterday also, if you have to construct a state space model, then you have to show all the steps. If you just want to write down in second companion form, you can just write down by inspection. Clear? Clear to everybody?
Yes, sir.
Just go through this lecture, just go through the steps and see whether you can follow the steps properly. In case you face a problem somewhere, you can just repeat the lecture. You can record it already, you can repeat it again and again. And उसके बाद भी अगर कोई problem हो, then you can tell me in the next class. Is that clear?
Yes, sir.
So that's enough for today. The next lecture will take up the third canonical realization, that is Jordan's canonical form or diagonal form realization of the transfer function. Okay, any query or any question?
Excuse me, sir.
Yes.
So what about control systems lab? We were informed it would be on Thursday. So are we supposed to
Yes.
come to campus?
Those of you who can come to campus, they are welcome. We'll actually appreciate if you can come to the campus. Some students have already committed. They'll be coming. So I would request जो श्रीनगर district से जो भी students हैं, अगर वो सभी आ पाएं, तो lab अच्छे से हो पाएगी. Because we'll have some students in physical mode. We'll be recording these videos of the labs also, and those will be put for those students who actually are not in a position to come to the institute.
So what will be the timing?
I mean, it will be at 2:30.
Okay, sir. Thank you, sir.
Okay. Anybody? Anything else?
सर कोई भी आ सकता है सर?
Yes. आपकी आवाज सही से नहीं आ रही है.
सर आई मीन कोई भी आ सकता है सर, हम भी आ सकते हैं, हम श्रीनगर से नहीं है सर.
आप कहाँ से हो?
शोपियान से.
हाँ, कोई भी आ सकता है.
ओके सर.
कोई भी आ सकता है. So you can come and just have a look at the lab also, and then you can have a feel of the lab also once you come to the lab.
Okay.
Have all of you submitted the tutorial?
Yes sir.
All of you have submitted it. Okay. And the second tutorial will be giving by the end of this week. So you will have some practice examples. And what's the feedback so far regarding the course? Is it going okay?
Yes sir.
In case you feel any problem anywhere, just communicate it to me. Thank you for today. The class is already over, so you can just join the new class, other class.